The first liquid-fueled rocket was developed by Robert H. Goddard in 1926, which turned out to be the progenitor of the Saturn V rocket that launched 43 years later and is still the most powerful rocket ever launched in the world. Rockets need to travel over 25,000 miles per hour or 7 miles per second to reach escape velocity, and they need to have a lot of power to achieve this. But just which rocket engine is the most powerful? When it comes to Soviet rocket engines, the Nk-33 was among the most powerful liquid oxygen refined petroleum rocket engines in the world when it was built in the 60s and 70s. The Nk-33 were designed and built for the ill-fated Soviet N-1 moon rocket, but they are still in production and are now used on the first stage of the Soyuz Tu-1V launch vehicle. These high-pressure, regeneratively cooled stage combustion cycle propellant rocket engines use oxygen-rich preburners to drive the turbopumps that supply the fuel. These pumps get so hot that they require subcooled liquid oxygen to cool the bearings. Thrust performance is incredibly high for a rocket engine of this era, putting out 340,000 pounds force of thrust at sea level. But this rocket engine is highly unusual since the hot, oxygen-rich exhaust tends to attack metal and can cause burn-through failures. To combat this, Soviet engineers constructed the nozzle from corrugated metal brazed to an outer and inner lining, resulting in a light but very strong structure. Since the engine uses liquid oxygen and refined petroleum that have the same density, it can take advantage of a single rotating shaft for both pumps. The Nk-33A engine has among the highest thrust-to-weight ratio of any Earth-launchable rocket engine. Many of you know there are still plans to send humans to Mars, and testing has been underway for a rocket engine that will be powerful enough to get the job done. The Aerojet Rocketdyne RS-25, also famously known as the Space Shuttle main engine, is a liquid-fueled cryogenic rocket engine that was designed and used on the successor of the Space Shuttle, the new Space Launch System. The RS engine has gone through many upgrades since then. It burns cryogenic liquid hydrogen and liquid oxygen propellants, and each engine has a liftoff thrust of 418,000 pounds of force at sea level. The Space Shuttle orbiter had a cluster of 3 of these engines that were mounted in the stern and fuel coming from the external tank. Those 3 engines could generate the equivalent of 37 million horsepower. The new RS-25D engines are currently under development by NASA, along with the SLS vehicle, which will use 4 of the modified engines which were left over from the Space Shuttle program. Together with 5-segment solid rocket boosters that produce 3,600,000 pounds of force and the 4 RS-25D engines, the first mission should be able to send 81,571 pounds of cargo, equipment, Orion, and crew into deep space. Total thrust of the space launch vehicle with all of the engines is estimated to be around 7,200,000 pounds of force. Block 2 will have the most powerful rocket engines and boosters. Together, the rocket would have the capability to put 130 metric tons of cargo into low Earth orbit. To put that into perspective, 4 adult African elephants weigh 26 metric tons. All that technology and development puts the program cost at $7 billion. The Merlin family of rockets is being built and developed by SpaceX for use on its Falcon and Falcon Heavy launch vehicles. There are several variants of the Merlin, including the 1C, which has a sea-level thrust of 78,000 pounds of force. It uses a regeneratively cooled nozzle and combustion chamber and mixes refined petroleum and liquid oxygen as fuel. The Merlin 1D is the latest variant and was developed by SpaceX between 2011 and 2012. The performance goal for this engine is to reach 155,000 pounds-feet of force. On November 24, 2013, Elon Musk told press media that the engine was operating at 85% of its potential, and they anticipated they would be able to increase the thrust power to 165,000 pounds of force, and a thrust-to-weight ratio of 180. Falcon Heavy is considered to be the most powerful operational rocket in the world by a factor of 2 or so, says SpaceX. The first-stage rocket uses 3 Falcon 9 9-engine cores for a total of 27 Merlin engines, cranking out 5,130,000 pounds thrust at liftoff. That's the equivalent of 18 Boeing 747s at full takeoff thrust, with all 27 engines at full throttle during liftoff. The Falcon Heavy can sustain an engine failure and still successfully complete its mission. It sounds like SpaceX has a good thing going with such a powerful setup, but everyone has their competitors. The Delta IV Heavy has the Aerojet Rocketdyne RS-68 liquid-fueled rocket engine that uses liquid hydrogen and liquid oxygen as propellants in a gas generator power cycle. The RS-68 has something special about it because it's the largest hydrogen-fueled rocket engine ever flown. Development started in the 90s for a heavy-lift engine for the Delta IV launch system, and the RS-68 is part of each Delta IV common booster core. 3 of the booster cores are mounted together. At its maximum 102% thrust, the RS-68 engine can produce 663,000 pounds at sea level. The engine's mass is 14,560 pounds, giving it a thrust-to-weight ratio of 51.2. The new RS-688 that is in development is proposed to have a thrust of over 700,000 pounds of force at sea level. The Delta IV Heavy rocket is still being used to put satellites and other cargo into space, and it has a liftoff thrust of 2.1 million pounds. Even though the engine is powerful, it would need over 200 changes for it to receive a human rating certification so that it could be used to put astronauts in space. One of the things about this engine that makes it very attractive is the price of only $20 million each. The Ariane 5 is a European heavy-lift launch vehicle that was designed by the French government space agency to carry over 20 metric tons into low Earth orbit. The Ariane 5 needs a lot of power to push all that weight into space. Enter the Vulcan 2, a gas generator cycle rocket engine fed with cryogenic liquid oxygen and liquid hydrogen that uses regenerative cooling through a tube wall design. The Vulcan 2 has been called Europe's most powerful rocket engine in use. It has an oxygen turbopump that rotates at 13,600 RPM, and the hydrogen turbopump rotates at 34,000 RPM. This gives the Vulcan 2 a vacuum thrust of 310,000 pounds of force. Total liftoff thrust for the Ariane 5, which, coincidentally, uses 5 Vulcan 2 rocket engines, is around 3,180,000 pounds-feet of force. And with the Ariane rocket weighing 780 tons, it needs all that power. First designed and produced in the Soviet Union from 1976 to 1987, the 21,500-pound RD-170 is often referred to as the world's most powerful multi-combustion chambered liquid fuel rocket engine. NPO Energomash designed this particular rocket for the Energia launch vehicle. The powerful engine that consists of 4 combustion chambers and 4 nozzles burns refined petroleum, fuel, and liquid oxygen, which is supplied by one single-shaft, single-turbine turbopump rated at 230,000 horsepower in a staged combustion cycle. Just one set of turbines and pumps produces the equivalent output power of 3 nuclear icebreakers. The result is an amazing 1,631,000 pounds force at sea level, or about 740 tons. This engine was the first used on the Zenit rocket in 1985, and then on the Energia launch vehicle in 1987, which was produced by NPO Energia as a heavy launch vehicle. The Energia used 4 strap-on boosters which were each powered by a 4-chamber RD-170 engine and a central core stage with 4 one-chamber RD-0120 engines that are fueled by liquid hydrogen. The total thrust of all those engines is around 6,500,000 pounds of force at sea level. That's enough thrust for the Energia to place about 100 tons of cargo in low Earth orbit. The massive rocket made only 2 flights into orbit, once in 1987 and then again in 1988. There is a rumor of a more powerful rocket being designed off the RD-170 called the RD-173, but information is scarce on what it would be capable of or if Russia will have a use for such a powerful rocket. The RD-170 is very powerful, but keep in mind that it is a multi-combustion chamber rocket. That brings up the question, what is the most powerful single combustion rocket engine ever built? The Rocketdyne F1 is a gas generator cycle rocket engine that was developed in the United States during the last part of the 1950s and was used on the Saturn V rocket in the 60s and early 70s. The F1 is the most powerful single-nozzle liquid-fueled rocket engine ever flown. It was built on a requirement from the U.S. Air Force to be a very large rocket engine. In fact, it was so powerful that the Air Force halted its development because there wasn't any use for such a large engine. It was NASA that contacted Rocketdyne to complete its development of the rocket, and the first engine was delivered in December of 1964. The engine wasn't perfect, and there were problems at first with combustion instability. But eventually, the engine combustion was so stable it could self-damp artificially, including instability within 1/10 of a second. When this rocket was used, it burned rocket-grade kerosene and liquid oxygen. The F1 engine has a gas generator that drives a turbine that spins at 5,500 RPM and produces a whopping 55,000 brake horsepower. We're just talking about the fuel pump system here. At top RPM, the fuel pump would deliver 15,471 gallons of refined rocket-grade kerosene per minute, while the oxidizer pump delivered 24,811 gallons of liquid oxygen per minute. Sea level thrust at a maximum was 1,522,000 pounds-force, and the Saturn V vehicle used not one, but 5 Rocketdyne F1 engines. However, based on the actual measurement, the total liftoff thrust of Apollo 15 was 7,823,000 pounds of force. That gives the F1 an average thrust of 1,565,000 pounds of force, which is slightly higher than expected. Saturn V was powerful enough to launch 130 tons into orbit, along with its 6.2 million pounds. The interesting thing is that no one really knows how the Saturn V got its power. 4 different contractors built the parts, and NASA engineers put it together. NASA now has a team of engineers resurrecting and reverse engineering this rocket engine to learn its secrets. It is very possible that it is being considered as a rocket engine to take us to other planets and could be used on the space launch vehicle of the future. We hope you enjoyed the video, and we want to know what you think will be the most powerful rocket in the future. And if you liked the video, then make sure to click on the subscribe button and turn on notifications so you will be the first to know when a new video is released. Thanks for watching.